Okay, so now I have y is equal to 4 over root x. So this is the same as 4 times 1 over root x. That's how you kind of want to think of this. Or we can rewrite this as y is equal to 4. And remember, root x is the same as x to the power of 1/2. So I'm going to actually break it down. So y is equal to 4 times 1 over x to the power of 1/2. That's what that means, right? Converting from a radical to power form. Now, in order to apply the power rules, I need a power. There's no powers here, so I need to well, the power is hard to determine. So I want to rewrite this as 4 and x to the power of -1/2. Okay, so that's how I got to. You can typically really get to this in one step, but I broke it down a little bit further because I wanted you to see the various steps, okay, or how I got there. Okay, so now I need dy of dx. I need to solve for the derivative. So first of all, I'm taking that -1/2 and bringing it down. So I have -1/2. And I could write the 4 first. I could then write the -1/2 first. It doesn't matter. -1/2 times my 4. Then I have x to the power of -1/2. I have to remember that I need to subtract 1 from that. And really, you could do that in your head, but because I'm teaching, I'm going to write out all the steps I can possibly can. So -1/2 times 4, and then I have x to the power of -1/2. Change it to common denominator, so -2 over 2. dy over dx is going to be equal to, those two numbers I'm multiplying together. So I have -2, and when I simplify my negative powers, I have x to the power of -3 over 2. It would only be part marks if you leave it like that. I need to go one step further. dy over dx is equal to -2. And in my denominator, I have a 2 as my index with x to the power of +3 as my power over there. Okay, is that me or is that someone else? Okay. Yes.
If we were writing this on a text, for example, we have to write 2 as the index because it's square root, right?
Yes, if you wouldn't get marks off if you didn't put that index there for a square root. However, if it's a cubic root or a quartic root, you have to write the index. It's just good practice. For you guys, I would recommend always writing the index because then otherwise you're training your brain to forget writing it, okay? So I would really prefer if you wrote it, but of course I wouldn't ever take marks off for that. Okay, can you take a second to write these? So even though we're not going to put any word problems on the test, we did go over in the lesson how to do this. Determine the slope of the tangent to the graph of each function at the indicated value. So remember the slope of the tangent to the graph. We can't say the derivative is just the slope of the tangent. It's the slope of the tangent to the graph. And yesterday, or in the videos for both power rule and product rule, I did show how we can go from the slope of the tangent to the graph using a particular point on the graph to find the linear equation of the tangent. That process is a much, a three-step process, but the derivative is only the slope of the tangent to the graph. Okay, so that's why you don't want to get confused, as Nicholas pointed out yesterday, that if you have a quadratic function when you're getting the derivative or a cubic function, that's just to help you find the slope of the tangent to the graph. Take a second to write that out. Okay, so y is equal to 6 at x is equal to 12. Now this, can someone tell me why this would be a very important question? I mean, easy question, not important, but easy question to tackle. What do we know about constant numbers? Constant numbers always have, Chantal?
Derivative of constant numbers is always 0.
Yes, the derivative of constant numbers are always 0. So it doesn't matter at what point we're looking at, the derivative is going to be equal to 0. But I want you to write, to know the proper notation. So dy over dx at x is equal to 12 is equal to 0. So when you see this in your Unified and your textbook, that's simply what it means. Okay, f of x is equal to 2x to the power of 5 at x is equal to root 3. So that means that f prime of x, notice I'm not using dy over dx because my original function is f of x. So f prime of x would be taking this power of 5, bringing it down, multiplying it by 2x to the power of 5, but we have to subtract 1 from my power. So that gives me 5 times 2 is 10. I don't really need a bracket there. So 5 times 2 is 10. And then I have x to the power of 4 as my final answer. But that is f prime of x. Because the question is telling me at x is equal to the square root of 3, that means I'm going to substitute into the equation at root 3. I have 10 root 3 to the power of 4. So I'm basically substituting root 3 everywhere that I see an x. And we're going to do this step by step. So f prime of root 3 is equal to 10. Root 3 to the power of 4 is the same as 3 squared, or the same as 9. So my final answer, the slope of the tangent to the graph is going to be equal to 90. So that's a very large and steep slope. And finally, but what would you do and how would you do proper notation when you have y is equal to at x is equal to -2? So I'm going to show you how to do that. So I can rewrite this function as y is equal to, now again, you need to know how to deal with those denominators or how to write the power properly. Is 1/3 x to the power of -1. Not 1 over 3x to the power of -1, 1/3 times x to the power of -1. When I do my dy over dx, I have to remember to bring down that -1, multiply by 1/3, subtract 1 from the power, so x to the power of -1 minus 1, so dy over dx is going to be equal to -1 over 3x squared, because this is -1/3 x to the power of -2, or actually, maybe I should write that just so no one is confused. -1/3 x to the power of -2, and we can move from that to dy over dx is equal to -1 over 3x to the power of +2. Now, when it comes to substituting my point in, I can write it as dy over dx. At the point, x is equal to +2, and now substitute it straight into the equation as -1 over 3 times, oh, I'm sorry, it was supposed to be when x is equal to -2. So -2 squared, which gives me a final answer of -1 over, -2 squared is +4 times 3, -1 over 12. Okay, I'll look for it. Okay, so I'm wondering, I'm going to do a few more, and then I'm going to post a few more examples as well, so that I'm going to give you a chance to do them in class, and then check your answers at the end. Okay, so we're just going to focus on power rule today. So you can see, even though it's the simplest rule, you can apply it to more complex questions. Tomorrow, when I have the other cohort, I'm going to do a video with examples of the product rule. Even though I'm teaching them the quotient rule, I'll also go over some examples with product rule. Okay, so let's see. I want you to do, this one is very simple. F prime of x is going to be equal to, when I bring this power of 2 down and multiply it by 2x, I have to remember I'm not finished because there's another term in that equation. So I have to essentially apply the power rule twice. I'm bringing the +3 down, and what did I forget to do right now? I forgot to subtract 2 minus 1. So actually, this would be incorrect. The way I just wrote this would be incorrect. Can someone tell me why? What did I put in around the 2x? Yes, I put brackets. I shouldn't put brackets because when I'm applying the power rule, the power, the subtracting 1 from the exponent only applies the x squared. It doesn't apply to the 2. So I did that by mistake, but it's a good thing I did that because you have to be very careful where you put your brackets. So let's try that again. I'm bringing 2 down. I'm multiplying by the 2 that's already there, but the x squared, I want to keep that separate and subtract 1 from that power. Now I have the x cubed that I have to deal with. So I'm going to bring the 3 down. I have my x cubed that I have to subtract 1 from. So that means that f prime of x is equal to 4x plus 3x squared. Now you don't have to show all those steps of subtracting. You can do that in your head if you would like, but if the test question is worth 2 marks, that means we're asking you to show at least 2 steps. If the question is only worth 1 mark, then you can just write the answer down, okay? So it's always important to pay attention to how many marks the question is worth. For part B, I'm going to do that down here. We have y prime. We can write dy of x, or we can write y prime. I'm going to stick to dy over dx. It just makes it easier. So this time I'm not going to circle anything. I just want you to follow me. I have the x to the power 5 that I want to bring down and multiply by the 4 over 5 that's already there. And then I have x to the power of 5. I want to subtract 1 from that. For the second term, x to the power of 1. So I can't forget the subtraction sign, but I'm going to bring the 1 down, multiply it by the 3 that is already there, not -3 because I'm putting the negative already over there. And then I have x to the power of 1 that I have to subtract 1 from. So because this 5 cancels out with this 5, my final answer is dy over dx is equal to 4x to the power of 4 minus 3, because x to the power of 1 minus 1 is equal to x to the power of 0. I want you to try this one on your own in terms of the steps. And keep in mind that whenever you see a constant number, you want to kind of circle that constant number and put an x through it, because all constant numbers are 0. So when you apply the appropriate rules, we can write this as h prime of t is going to be equal to -4.4 x cubed. And I'm going to leave it to you to do the steps on your own. Okay, let's go to some difficult questions right now. So these are difficult because we have lots of fractions and we have some radicals, but we're still applying the power rule. So I have P of A for the first one. P prime of A is going to be equal to. Now I want to see if you can follow me if I do not convert this question into another form. I'm not going to convert it to have any negative exponents or rationals. I just want to see if you can follow me, because I can do that in my head. I want to see if you can. And be honest with yourself, if you can't do it in your head, then you have to write it down in alternative format. So I have a to the power of 5. I'm going to bring that down. So I'm going to bring the 5 down. I have a, or actually before I get to the a, I have to multiply it by 1 over 15. And a to the power of 5 minus 1. Then I have minus, remember this is a to the power of 1/2. So when I bring the 1/2 down and multiply it by the 2 that's already there, I have a to the power of 1/2 minus 1. Now, if that was complicated for you, you know you have to convert it to powers with fractions first. So that leaves p prime of a equal to 1/3 a to the power of 4 minus 1 over root a. Many of you will need steps in between, but I want you on your own to figure out the steps in between. So if you cannot get that as a final answer, you need to consult with me. For the next question, I definitely want to rewrite the question first. So I have k prime of s. I want to rewrite, so not k prime of s, I want to write it with the equation the way it is. I want to rewrite the question first. So instead of -1 over s squared, I want to write it as -1 s to the power of -2, and then plus 7s to the power of 4. It makes my life a lot easier because I know I have to bring, when I solve for k prime of s, I have to bring that -2 down, multiply by the -1 that's already there. I have s to the power of -2. I need to subtract 1 from that and add that, and sorry, now take this +4, bring it down, multiply by 7. Notice just the 7 in brackets, s to the power of 4 minus 1. And that gives me k prime of s is equal to +2 over, because s to the power of -3 would become over s to the power of +3 plus 28 s to the power of 3. Okay, I am going to stop right there because you can see how we can take a simple power rule and apply it to questions that you really rely on your grade 9 skills as well as your MCR skills to solve. And that's why we call it gaps in knowledge, because if there is any gap, you kind of fall right through and you get stuck. So foundation, that's why we've been always stressing foundational skills.